Hello and welcome to a demonstration of my final year project, Modelling Attacks on Network Simulations. I am Nicholas Taylor and my project manager was Guido Schmitz. So the application I have developed demonstrates how network protocols are implemented and how they can also be exploited. So to start with, on the left hand side here, we have a table that will list all the packets that have been sent in a network. And on the right here we have a graph of the devices and connections in a network. So for example, here we have a DHCP server and two computers, and information such as their MAC and IP addresses is also shown along with relevant data to each different simulation. In the top of the graph is an indication of system time, which I've shown as an abstraction of the concept of time, and this is used to control each different simulation. Now, if you want to learn more about each simulation in more detail, you can click the About in this top bar and click Information, and a window will launch with a brief explanation about what the program in general is, and then each of these buttons goes through and gives an explanation in more detail of each of the individual simulations. So I've decided to develop the application to start with using DHCP. I didn't show any attacks on this, but this allowed me to construct the network simulator and have a basis to build upon with the other simulations. So here you can see an explanation of the DHCP simulation, which is in the background as well. I've also shown a denial of service attack on the ARP protocol. Again, that's shown there. A man in the middle attack, which is a passive attack on ARP. And also a denial of service attack using TCP, which would be TCP SYN flooding. So if we go up here, there's a list of all the different simulations. Clicking each one of these will load up a simulation into the program. For example, click DHCP, that is the default simulation. These buttons at the bottom, play will increment all the way through and play the entire simulation in one go. Next step, that will simply increment system time by 1, as we can see here. So as you can see, some packets have been generated. So the idea with the DHCP simulation is to show how a host can connect to a DHCP server and gain an address. The reason I chose this to start with was because all hosts on a network have to have an IP address in TCP/IP, so this simulation seemed a good idea to start and build upon. So we can see here the DHCP server has gained its own address, as have the two hosts in the simulation. They've also gained MAC addresses as well, and the TTL value here shows the remaining lease time of each address. Was sent by, that's a broadcast address, as the host does not yet have an IP address allocated to it. It was also sent as a broadcast address as the host does not know anything about the network. So it's just attempting to reach any DHCP servers on the network. Here we can see that the source MAC was beginning with 50C, so this was sent by the first PC on the network. The protocol is obviously DHCP, and the first packet type is discover, as the PC is attempting to ask any DHCP servers on the network to give them an IP address. And then afterwards you can see that PC, the server replies with an offer with a lease time of 4, and that address 195.10 can be shown here as well. So the request and the ACK then solidifying the fact that this PC has now gained an address, and as you can see, if we click play and let the rest of the simulation run until system time 16, now you can see here that the device, the lease on the IP address ends at system time 4, so a new DHCP conversation is started. Same happens here again at 5, and so on. If I want to show that incrementally, click next step, and go through, see nothing happens with that click or that one, whereas then system time jumps to 5 and you can see the TTL times decreasing. Now moving on to the first ARP simulation, so this doesn't update until you click next, but that is a fault with the Java effects library that I've used. I couldn't find a workaround for that, unfortunately. So this is a ARP cache poisoning attack. We have Mallory, who is the malicious actor, Alice and Bob, who are the legitimate actors. So the goal of this simulation is to show how ARP conversations work, which will be requests and replies. So for example, you can see Bob is establishing his ARP table, so he's attempting to resolve Alice's IP address to her MAC address. So you can see up here a request to Alice, which is then resolved in Bob's ARP table shown here. Then if we move through, Alice also updates hers. And then Mallory then corrupts Bob's ARP table by poisoning it with a false packet with a falsified MAC address. So what's happening here is Bob now believes that Alice has the MAC address of FFFFF, which she doesn't. So any more data that Bob sends to Alice will just be sent to the void, which is shown here by an FTP packet, which never reaches Alice because it's sent to the incorrect destination IP. Yeah, there you go. So you can see it sends the incorrect MAC address. So moving on to man in the middle attack. So in this simulation, Mallory is attempting to steal Alice and Bob's data by acting as a passive adversary and monitoring traffic. So the goal of Mallory is to poison both Alice and Bob's ARP tables. So that when Alice sends Bob data, it first goes to Mallory. Mallory can read the data and then it goes on to Bob. So as you can see, moves through. They all set up their ARP tables first. Then Mallory goes to work on corrupting Alice and Bob's ARP tables. So as you can see, all of their they both point to Mallory. Then we've got some FTP packets here which are sent first to Mallory and then to either Bob or Alice, so they don't detect Mallory. Lastly, we have the TCP SYN flooding attack, which if we come on here, so this is designed to show TCP handshakes, the three-way handshake. So to start with, so source IP 181, so that would be Alice, attempts to log a communication, a handshake or connection with the server, which is, as you can see, synchronizing with a sequence of 16510. The server then replies with an acknowledgement packet and increments the sequence number to indicate that Alice's packet was received correctly. Then Alice acknowledges this connection, that she is happy to start the connection by finishing the handshake with the ACK packet, and the sequence is incremented again. Now next, Mallory throws a bunch of SYN packets, each with a different IP, at the server, and as you can see, the server will send a SYN ACK packet to signify that it has registered the connection attempt and is now waiting on an ACK packet back from Mallory, but Mallory will never send this, will change his IP and then send another SYN packet. Now this will fill up, eventually it will fill up the connection buffer in the server, and as you can see, the server no longer replies because its connection buffer is full. So Mallory is just sending more and more requests, which then lastly here you can see Alice is trying to send a legitimate request 181.164, which is there, and she gets denied because Mallory has effectively crashed the server. Thanks for watching.